Question number 59. This type of question is very difficult. No, not difficult, but they are very logical questions. If you have basic knowledge, then you can do this type of question easily. What is the question? Construct. Please see the carefully. Construct leave it. Construct. How many number of DFAs? Check. How many two state DFAs with a designated initial state and a designated final state can be constructed over the alphabet sigma equal to a comma b. Please try to understand this question. What do you mean by the designated initial state and designated final state? It means initial and final state are fixed. Clear? Now, try to this question. Designated means initial and final states are fixed. Do fast. Okay, see solution. See the solution. Two states are given. What are the input symbols? A and B. Q0 and Q1 is given. Suppose I fixed Q0 as the initial state and Q1 is the final state, because it gives to the question initial and final states are fixed. Then how many two-state DFAs are possible? What is the possibility of A on Q0? There are two possibilities. It goes to the Q0 or Q1. Clear? It means there are two possibilities. Okay. Either A goes to Q0 or Q1. It means there are two possibilities. Same here. On B, either goes to B, Q0 or Q1. Same on Q1, same on B. it means total DFAs that satisfy this condition equal to 2 into 2 into 2 into 2, 16. Please check. Please check this question. Clear? Now, come to the next question. Come to the next question. If this is not given, this is not given, how many two-state DFAs with a designated initial state can be constructed over the alphabet A, B? Now, try to do this question. After 2 or 3 minutes, I will explain you. It means only initial state is fixed, final state is not fixed. Try to do this question fast. Okay. See the solution. Initial state it fixed, but final is not fixed. Input alphabet is A, B, Q0 and Q1. I fixed Q0 as the initial state. Then there is two possibility. There is two possibility. There is two possibility. There is two possibility. This is for no final state. Is it also possible? No final state. This is initial. There is no final state, neither Q0 nor Q1, because final state is not fixed. Clear? This is the case 1. Case 1. How many number of DFAs? 16. Second case. Case second. Q0 is fixed. This is the initial state. Q1. Q0 is also a final state. Then there is two possibility. There is also two. There two. Why two? On A, either it is goes to 0 or either it is goes to 1. Clear? Either on A we can move Q0 or Q1. Then total possibility, total number of DFAs 60. Clear? Q0 is final. This is also possible. Next case. Case number 3. Q1 is the final state. Initial is fixed, but final is not fixed. So we can make also Q1 is final. Q1 is final. This is 2. This is 2. This is 2. this is 2. Then this is also 16. Clear? Clear? Now, case 4. Case 4. Both are final. This is also possible. Q0 is also final. Q1 is also final. This is possible. There are also two possibilities. These are 16 DFAs. Then total number of DFAs 16 plus 16 plus 16 plus 16. Total DFAs that satisfy this condition equal to 16 plus 16 plus 16 plus 16 equal to 64. Clear? Now check. Please check this. Clear? Now, check another type of question. Another condition that involved in this question. How many two-state DFAs are possible? Two-state DFAs can be constructed. This is also not given. This is not given. This condition is also not given. Okay. How many two-state DFAs can be constructed over the alphabet A, B? Now, try to do this question. Here, initial state can be changed either Q0 or Q0. There is no possibility. Always DFA contain exactly one initial state. Every DFA contain exactly one initial state. Check. Here is 1, A and B. Q0 is the initial state, then there is 16 DFA, AB, Q0, Q1 is the final, 2, 2, 2, 2. There is also 16. Case 3, A, B, Q0 is the final state, 2, 2, 2, 2. 16 DFAs, 16 DFAs. Case 4, this is case 3, case 4, sorry, case 2. Now, case 4. What is case 4? Both are final state. Q0 is also final and Q1 is also final. 2, 2, 2. These are total 64 DFAs. Now, change the initial state. Change the initial state. Change the initial state. Case 5. A, B. Q0, Q1 is the initial state. There is no final state. Then 16 DFAs. In case 6, AB, Q0, Q1. This is the final, 2, 2, 2, 2. These are 16 DFAs. Case 7, A, B, Q0, Q1. This is initial and this is same as final. 2 possibilities, 2 possibilities, 2, 2. These are also 16 DFAs. Case 8, A, B, Q0, Q1. This is initial and final. This is final. 2, 2, 2, 2. 16. Total number of DFAs. 16 into 8. 16 into 8. It means 128. Total number of DFAs that satisfy the following condition. Total DFAs 16. 8 times. 16. 16. 16. $128. Is it clear to you? Please check. Okay. Shall we move on next question? How many two-state DFA can be constructed with a designated initial state that accept empty language? Question number 60. How many two-state DFA can be constructed with a designated initial state that accept the empty language. Please try to do this question. Empty language means 5. over the alphabet A comma B. Initial state is fixed. Now check. Total DFA has possible 64 that satisfy this condition. Sorry, not this condition. That accept no. Total number of DFA is 64 if this condition is not given. Okay. How many DFA is possible from 64 that satisfy this condition? Empty language means there is no final state. Empty language means there is no final state. If we traverse a string that never end with the final state, that never end with the final state. See, A and B. Suppose Q0 is initial state. If there is no final state, it means that DFA accept the empty language. That DFA accept the empty language. So there are two possibilities. 2, 2, 2. So 16 DFAs. From this, we can get 16 DFA. Those not accept empty language. End. Other than this 16 DFA, many DFAs are possible. Those not accept any string. See, A and B. If Q0 is the initial state is final, that means DFA accept something. Clear? Then, if this DFA is fine, if this state is final, then what are the possibilities that DFAs accept empty language? This is the Q0 and Q1. This is the final state. Please check how many possibilities are there. A and B. First possibility is this. This is not accept any string. Clear? Next possibility, Q0. A and B. A. Q1. B is here. Next possibility. B. A. Next possibilities. This is also a DFA. This is also a DFA. These are extra 4 DFAs that accept empty language. So total number of DFAs that accept the empty language with 2 state 16 and 4. 20 DFAs. 20 DFAs. 20 DFAs are possible. Please check this question. Clear? Shall we move on next question? Next question. Question number 61. Question number 61. That accept the universal language. That accept the universal language. That accept the universal language over the alphabet A, B. What do you mean by the universal? A plus B का whole star. Try to find for this. Find out the number of DFAs that accept the universal language. Okay. If both states are final, Q0 and Q1, it means it accepts the universal language. There are two possibilities for this two, for this two, for this two. These are 16 DFAs. These 16 DFAs accept the universal language. Rather than this, many DFAs are possible, those accept the universal language, which are, if Q0 is the initial and this is final. Okay. This also accept the universal language. Clear? This also accept the universal language. This also accept the universal language. This also accept the universal language. Clear? Then total number of DFAs are possible that accept the universal language. How many? 16 plus 4. 16 plus 4 means 20. Clear? Please check. Question number 62. What is the question? See. How many 3-state DFAs can be constructed with designated initial state given alphabet is AB. Given alphabet is AB. See, what are the possibilities? Case 1. There is no final state. There is no final state. Each state have 3 combinations. Clear? So total number of DFA possible for this case 3 to the power 3 की power 6. Case 2. One state is final. Suppose Q0 is final. Q1 and Q2 are non-final. Also this have 3 possibilities. No, total DFAs for this 3 to the power 6. Now whenever we have Q1 is final, then again 3 to the power 6. Q2 is final, then we have 3 to the power 6. Now out of 3 states, we have 2 states are final. Out of 3 states, we have 2 states final. Each combination we have 3 to the power 6 DFAs. So this is 3C2 combination and each have 3 to the power 6. Plus every state is final. Out of 3 are final. 3C3 into 3 to the power 6. So add these all cases. So first is 3C0, next is 3C1, one state is final, 3C2 plus 3C3 into 3 to the power 6, because each case have 3 to the power 6 DFAs. Okay. So now this is 1, 3 plus 3 plus 1. Into 3 to the power 6 into 3 to the power 6. Clear, my dear friends? So how many total number of DFAs? 8 into 3 to the power 6. We can write this as 2 to the power 3 into 3 to the power 3 into 2, where this is the number of states, this and this are number of states, and this is the number of input alphabets. So we can generalize this in next question. Okay, are you getting my point? See, next case, question number 63. Total DFA with designated initial state and n number of states with m alphabet See, if initial state is designated, then 2 to the power n into n की power n into m, where n is the number of states and m is the input alphabet. If designated state is not given, initial state is not designated, then total number of DFAs are possible. N into 2 की power n की power n into m, because we have suppose three states. So for the Q0 is initial, Q1 is initial, Q2 is initial. So we have n possibilities. So we multiply this term into n. Clear, my dear friends? Clear?